Like you guys said, all the transformations were the same. Can everybody see this okay? Or should I dim the light? Dim the light. Okay, so with our first absolute value function, we just have Abby and her significant points, okay? The line of symmetry is where could you fold your paper to get it mirrored on both sides. So where is it going to be symmetrical? So if I were to fold my paper along the line x equals 0, they would line up on each other, okay? So that was why your symmetry is at x equals 0. Your vertex is at 0, 0. Domain for absolute value is always all real numbers. So if you want to write that somewhere, I would. Okay, domain for absolute value is always all real numbers. So write that somewhere if you wish. Okay, your range for this one is y is greater than or equal to 0. Okay, it's not just y is greater than 0. Okay, it's greater than or equal to because you have a point at 0, 0. Okay, and in this case, because we open up, you only have a minimum. Okay, so when you're opening up, you only have a minimum, and then when you're opening down, you only have a maximum. Okay, so right now we have a minimum at 0 or when y equals 0. Questions on our first function? Okay, hopefully you guys did this already, so it should just be review. Number 1 was a reflection over what? Your x-axis. Very good. Okay, so same thing applies. We are outside of our notation, so it is a reflection over your x. Okay, outside of your absolute value, reflection over your x. Okay, domain, like I stated, is always going to be all real numbers, and your range was flipped on this one. It's less than or equal to 0. Questions on reflection over x? No. Okay, number 2. What transformation did you guys get? Reflection over y. So now we're inside of our parentheses, inside of our absolute value function. So now we have a reflection over y. Okay? Because we have symmetry with absolute value, when we reflect over the y, in this case, it looks the exact same. Okay? But there was indeed a reflection that did occur. Okay? Your vertex is still the same. Domain still the same. And now you're back to your original y is greater than or equal to 0. Okay, what transformation did we have on number 3? Up to, and what did you notice about the range? It's not 0 anymore, okay? It has changed to y is greater than or equal to 2. But the domain, like I told you guys, is staying the same this entire time. Domain for absolute value is always all real numbers. Okay, so all your y coordinates shifted up to. Okay, what else changed? Your vertex. Very good. Okay, what's outside of your parentheses? Okay, when it comes to your vertical translation up or down, okay, that's always going to represent your y coordinate. Y coordinate of your vertex. Oh, sorry. Y coordinate of your vertex, okay? What happens in number 4? Left 2 units. Very good. Okay? What changed? The vertex. Okay, so what's inside of your parentheses? First you take the opposite. Or inside of your absolute value. So take the opposite, and then it's your x coordinate of your vertex. What I circled for 3 and 4, these two things are the only thing that affect your vertex. So translations, I'm going to write it on the side here. Translations are the only thing that affect your vertex. So translations are the only things that affect your vertex. So do my stretches and compressions affect it? No, and my reflections don't either. Are you ready? Jacob, are you ready to do your test? Okay, awesome. If I can get you guys reviews and then you guys head to the learning lab, your tests are down there. Just bring a pencil. That probably won't take you very long, like 50 minutes, and then you can come back. Bye guys, good luck. Do great. Okay, moving on. Number, I don't know what happened to 6, 7, okay. What happens to 7? Vertical stretch by 2, okay. What changed in this case?
The Y value.
Did it? Well, the Y value is correct, changed, but as far as your vertex, domain, and range, nothing, okay? It looks exactly like your parent function. So notice how that 2 does not change your vertex. Because 2 times 0 is going to be 0. Okay, next one. What happens when you have 1/2 x? Vertical compression, did anything change in my vertex, domain, and range? No, the only thing that changed were your Y values. Very good. Okay, what happens when we're inside? Horizontal compression by what? 1/2. By 1/2. Okay, I don't remember if it was this class or maybe it was my other Algebra 2 class. Horizontal compression by 1/2 looks exactly like vertical stretch by 2, because algebraically they are the same. Okay, 2 on the outside of x is equal to 2x inside of the absolute value. Okay, so algebraically you're going to get the same answer. Okay, next one, what happens? Very good. Horizontally stretched by 2, and again it looks the same as a vertical compression by 1/2 because algebraically they are equivalent to each other. Okay, notice again that your stretches did not affect your vertex, your domain, or your range. Any questions on this? Was that the last one? Awesome. Any questions on Abby? No? Okay. Get out that gold summary sheet. As always, we're going to finish a lesson with a summary chart, okay, so that this can be put in your binder and easy to access. Okay, f of x plus c, okay, all it looks like is y equals the absolute value of x plus c. Okay, and so what's happening in my description? Up c. Okay, so you guys can write all these. These is x minus c, x plus c, and then we can discuss the descriptions. Okay, for the second one, y equals absolute value of x minus c, what happens? Down c. Okay, y equals absolute value of x plus c inside the our parallel bars, and what does that mean? Very good, left c. Next one, what do we got? Right c. Okay, negative absolute value of x. Reflection over the x. Y equals absolute value of negative x. Reflection over y. Y equals c absolute value of x. So what happens if it's greater than 1? Vertical stretch by c when c is greater than 1. And then what's our other option? Vertical compression by c when it is in between 0 and 1. So some sort of fraction. Okay, last one, y equals absolute value of c of x. What do we got? Horizontal compression by what? You want to do more than 1? So it is when c is greater than 1, but what is our scale factor that we do? So we're still greater than 1, but what do we have to do in here? 1 over c. So your horizontal compression is always 1 over c. And then you have your horizontal stretch by what? Is it just c? Is it just c, or what is it? What do you always do in the inside? If it's inside, what do you take? Oh my goodness, you guys, we just tested over this. The opposite. So it's still 1 over c, no matter what the value is. So even if you have a fraction, okay, you still take the reciprocal, which is the same thing, 1 over c. Okay, number 1, which transformations affect the domain? So when we went through that little Meet Abby activity, which ones affected the domain, Cameron?
When it goes left or right.
Did it affect the domain, though? Very good, Bree. None of them do. So remember that. Remember on our paper we wrote always, because none of our transformations affect the domain for absolute value. Okay, so what is our domain always? All real numbers. Okay, which transformations affect the range? Translations in which direction? Translations up or down? So your translations up and down affect your min and your max values. Okay, what else affects your range? Very good. A reflection over the x-axis. Okay, and all that I'm going to write here is it just changes your inequality symbol. So if you're above the x-axis, y is greater than or equal to 0. Once you reflect it over the x-axis, it's y is less than or equal to 0. Okay, which transformations affect the axis of symmetry? So if you were to fold it in half, which one is no longer x equals 0? Very good. Translations left and right. And I got a lot of like googly eyes on that one. So I'm going to show you. Okay, so our reflections, we still are symmetrical on our axis. Okay, when we go up and down, we would still be symmetrical on our axis. Okay, but when we go left to right, if I go along the line x equals 0, we're no longer symmetrical. I can't fold my paper right here and it be equivalent on both sides. Our stretches and compressions are going to also be at x equals 0. So all of these are still x equals 0. So the only thing that's going to affect it is moving left or right. Okay, which transformations affect the vertex? Very good. So up and down and left and right. So all of your transformations. Okay, which transformations affect the slope of each branch? Very good. So vertical stretches were equivalent to what? Horizontal compression. And what did that image look like? Did our slopes get bigger or smaller? So if I have an image like this and I stretch it to now this, are my slopes greater or smaller?
Greater.
Greater. Okay, so makes branches. Okay, and when we talk about slope, to say greater, we say steeper. Okay, that just means that incline is getting real steep. Okay, and vertical compressions were equivalent to horizontal stretches. And what happens then?
Big slope,
Less steep. Very good. Okay, so that's your summary chart. Make sure you keep that in a handy place. Are there any questions on these transformations? So they're the exact same thing as the last summary chart we filled out, except for now they pertain to absolute value functions as well. Okay, so without looking at your yellow paper, what is the domain for absolute value functions? Does that change? No. What things affect your vertex? Up, down, left, and right. Okay, do compressions and stretches and reflections affect the vertex? No. What affects your range?
Translation up or down.
Max, don't look at the paper.
Translations up or down.
And what else? Very good. Reflections over your x-axis. Vertical stretches, what happens to your slope? Steeper. Vertical compression, what happens? Less steep. Horizontal stretch, what happens? Less steep. Horizontal compression, what happens? More steep. Okay. Any questions on that? Alright, the first practice assignment that you picked up, I didn't bring a copy up here. Okay, it's single-sided? I think it actually might be double. No, it's just single-sided. Okay, I'm going to do a couple with you together, and then you're going to do the rest on your own. Okay, so let's look at, which one do you guys want to do? Anyone 1 through 8?
All of them.
No, 1 max.
8. Actually, number 8. 7. 12.
Okay.
All of them?
Well, I said 1 through 8. 12 doesn't even fall in the range. Okay, I'll do number 8. Sure. Okay, it says describe the following transformations on the function y equals absolute value of x. Identify the vertex. Okay, what happens in number 8? Reflection over what? X. Then what? Horizontal stretch by 2. And then what? Up 3. Awesome. So I described my transformations. Now it says identify the vertex. Looking at this, what is my vertex? 0, 3. Does everybody see how we got 0, 3 as a vertex? Okay, so you're not moving left or right any amount. Okay, so your vertex, your x-coordinate is going to be 0. Okay, and then you're moving up 3, so that affects your vertex. So that's the y-coordinate, and so you're going to add 3 to your y-coordinate. Okay, for your parent function, your vertex always is starting at 0, 0.
Yeah.
Does that make sense?
Yeah.
Okay, let's do one more. Pick one more.
Number 7.
Okay, sweet. 7. Okay, what do we have? Vertical compression by 1/3. What else? Left 2 and up 3. So what would your vertex be? Negative 2, 3. Got it, Mark?
Yeah.
Cool. Okay. Number 11, write the equation for y equals absolute value of x with the following transformations. Then identify your vertex. Okay, let's do 14. Awesome. Okay, what's it going to look like? Y equals what? Horizontally compressed by a factor of 1/3. Is that going inside my absolute value bars or outside? Inside. What is it going to look like? 3. Okay, we also have to shift left 2. So I need to put this in parentheses. Plus 2. Okay. Is my up 5 going inside or outside my bars? Outside. Okay. So just like with our linear equations, okay, you have to have parentheses if your coefficient is greater than 1 and it's attached to your x. So you've got to be able to pull out that 3. Okay. When you have it already in words, okay, that's easier because you literally just have to put parentheses around your left and right movement. Okay. Where is our vertex?
0, -1.
Negative 2 what? 5. Okay, so again, make sure you have your parentheses because I want to move all my x values left 2, not my 3x values. Okay, I just want to move my x values left 2. Questions on 14? Okay, I'll do 15 with you, and then you guys can do 16. Translate f of x equals absolute value of x so that the vertex is at the given point. Write the equation and then graph. Okay, if this is our vertex, okay, without even graphing it first, what is going to be the equation?
Y is
x minus plus, wait, no, minus 4.
Okay, absolute value of what? X. Open my bars, close them, what do I do? Close them, and then what?
Minus 4.
Minus 4. Very good. So all we did was go down 4. We didn't go left or right any because we're still at 0. Okay, so you go 0, negative 4. Plot your vertex. Okay, and then hopefully after our last test, okay, we know how to graph absolute value functions. Okay, so right now I just have a slope of 1, so I'm just going up 1 over 1 on each side of my vertex. And then I plot my line. Oh, I guess I could have wrote this up here. X minus. Okay, questions on what you're going to be doing on this? Okay, go ahead and go for it. I would complete this one by yourself because this is an easier one than the one that you'll pick up after this. Okay, the one you pick up after this, you might want to work with your table. Okay, so right now, Just work alone, make it through these, and then you can come check your answers up here, or I'll put them up there, and then you'll get started on the next homework sheet. Questions? Do you have questions? No? Awesome.